And just so you know, I am recording this. I am not recording your picture. So if you have a video on, your camera on, that's fine. You are not in the recording. If you answer a question or ask a question, that would just be on the recording. But I do have to record this for all of the students so that they have an idea of the questions and the material we're going over. So Mr. King is going to pop on and say hi. And then he's going to go over some questions with you. And they can see you through my camera.
Okay. Thank you. Hey everybody, Mr. King here. We're going to go over some questions. So if you want to look on the Pre-Algebra 2 pre-course test, we're going to start with number 7. And again, this is going to be due tonight. So I'm going to zoom in here, and it says solve the proportion. And we have 60 over 84 equals b over 7. And we want to show your work. So the first step for doing this is we're going to cross multiply. So I have the stylus here. Hopefully you guys pick one of these up. And I'm going to rewrite the problem. Okay, to cross multiply, what we'll do is we'll bring the 84 across and over to where the b is, and then the 7 will cross and bring over to where the 60 is. So if we go where the b, 84 times b, is this going to give us 84b? Next, if in your calculator you put 7 times 60, and then that's going to get you 420. So now we have 84 times b equals 420. Anytime to get rid of multiplication, you're going to divide. So we're going to divide now by 84. If you do it to one side, you also have to do it to the other. So then on your calculator, you're going to, we'll see that the 84s will cross out, and you'll be left with a b. And then 420 divided by 84 is going to equal 5. So for your final answer there, you'll have b equals 5. Another one that we want to go over with you is going to be number 16. So if you could find 16 on your paper. Now we're looking at some wording here in algebra, and this one says, write the phrase, the quotient of 3 times a number and 6 as an algebraic expression. So the one term that says quotient, this is a term you probably don't remember, maybe it was from Algebra 1. Well, anytime it says quotient, we're looking for multiplication. Okay, so it says 3 times a number. In math, if we don't know a number, we generally use x. So we're going to say 3 times x, or the way we write in algebra is 3x. And then it says, and there's a number 6. So we're going to add the 6 to the end of the expression. So your algebraic expression is going to be 3x plus 6. All right, we have 2 more examples we're going to do for the test. And remember this pre-test, it's not graded, but it is going to be due for submission tonight. So once we're done here, you'll have a little bit of time to finish this up, and then we also have a couple of homework problems for you. The next one we're going to look at is 17. And this one says, simplify the expression of combining like terms. Show your work. Okay. So if you notice, we have 2 times the quantity, y plus 3, minus 6 times the quantity, y minus 2. The first thing we're going to do is distribute our terms. We're going to distribute the 2 to the y and the 2 to the 3. So if we do that, we'll get 2 times y is 2y, and 2 times 3 equals 6. So we'll have 2y plus 6. Now we got to distribute the -6. And this is a part that a lot of students will struggle with, because if you notice, it's not just 6, it's a -6. So you need to distribute that negative through both ways. So it'll be -6 times y, and that's going to give you -6y. And lastly, you have a -6 times -2. A negative and negative give you a positive. 6 times 2 equals 12. So now that we're here, we're going to combine our like terms. If you notice, we have two different y's, and then we have two constants. So we have 2y minus 6y is going to give you -4y. And then our two constants that we have left over, a 6 plus a 12. 6 plus 12 is going to give you 18. So your final expression will be 4y plus 18. And the last one we're going to look at is using foiling. When I was going through your tests that were submitted, this is one that it seems like a lot of you are struggling on, so we'll definitely go over this. The FOIL is an acronym which means first, outer, inner, last. So I'll rewrite the problem just to give a little bit more room. Okay, first we start with the F first. So we look at the first term, that's the X, and we're going to distribute it to the other X. If we do that, X times X is going to give you an X squared. Now we go to the outer terms, which is the X and the -4. -4 times X is just going to be -4X. Now the I is your inner terms, which would be the +5, and the X, +5 times X, is a +5X. And then lastly, you have your last terms, which is +5 and -4. Positive times a negative is a negative. 5 times 4 gives you 20. Another way to think about doing this is you take your first term, which is the X, right here, you distribute that through the second expression. So you distribute it to the X, distribute it to -4. Once you're just done distributing that, you look at your 5. Okay? Then you can take your 5 and then distribute that through. Now that we have our expression, x squared minus 4x plus 5x minus 2, we look for like terms. Well, in this case, we have a -4x and a 5x. We can combine those. So if we do this, we'll get a +1x, or just x. So 5x minus 4x gives you just an x. We could bring down our x squared plus 1x minus 2, and then we have our final expression, which is a quadrant. Oh, sorry, 20. Virtual learning, sorry about that. Thank you. And then that's our final expression here. So please get these submitted today. We did 4 of them together. If you have any other questions, you can email us, and then I will be happy to go over. Again, this is just to see what you know, and they're not being graded as far as accuracy, but we just want to see you have effort for this. So I'll throw it back over to Ms. Kane, and looking forward to working with everybody.
So typically in the normal class, Mr. King and I would kind of be bouncing back and forth in the front of the room and working with you as one walks around the room and the other is teaching. But right now in this world that we're living in currently, he and I are just going to be back and forth on the screen, and then eventually, remember our student teacher, Ms. Karp, she will also start joining in on the lesson as well. And you can see her, she definitely has her video up back there, and I think Mr. King was popping his head in back on her video screen as well. So there are 3 of us that get to work with you, and you will see us. We keep our cameras on so you can kind of see us as well. So there is a math help session today from 3:10 to 3:30 that if you have any questions on this worksheet, we can go over those then as well. It is posted in your Google Classroom for this week, so just click on that link, and then any questions that you still have, we can work through them. But what I'd like you to do is if you could take out that packet of notes that I gave you the first week of school. If you weren't here last week, it was in the first week of school material. But this is what the cover should look like. And it was an actual packet of paper so that you can take notes with pen and paper or pencil and paper. Make sure you have your calculator out as well. So whether you're using like this calculator, some type of Texas Instrument graphing calculator, or this is just called a scientific calculator. You can even use the calculator on your phone if you have a phone next to you. But you're going to need some type of calculator. As I said, typically our notes will not be very long. We'll go through maybe a couple definitions and a handful of examples. Today we have a good number of definitions to talk about, and we'll go through maybe 2 examples, and then you can kind of start working on the homework. I will be remain on the Zoom until the end of the class period, which is at 11:25. So that if you want to continue working with us, you can, or you can just choose to work on your own and kind of leave the Zoom. So I am on the page, this is page 3 in your packet. This is the first section, so section 1.1. See if you can find that in the packet. Again, take notes regular way, pencil, paper, or if you prefer to use a pen. We're going to skip the warm-up, so we're going to skip this warm-up here. And we're going to talk about the different types of numbers. And you might not think about it very often, but there really are different types of real numbers. So real numbers is our big group of numbers, and there actually are imaginary numbers as well. If you take Algebra 2 next year, you'll get to see what those imaginary numbers are all about. But we're going to talk about real numbers and the types of real numbers. So this is kind of like a flow chart that it takes us down through the different types of real numbers. And we're going to work on the left side of the flow chart first. So we have our real numbers, and then the real numbers break down into more specific types of numbers. The further you get down to the chart, the more specific the numbers are, and the lower amount of numbers would exist. So the first type of number we have is called a rational number. So that is the biggest group of real numbers. They're called rational numbers. Rational numbers are values that can be written as a fraction. Sorry, I don't want the type. So any number that can be written in fraction form. So I'll say written in fraction form. So any number you can write as fraction would be considered a rational number. Now I'm going to give you a couple examples just so you know what I'm talking about. So 0.75, that can be written as 3/4. So even though it's a decimal, if we can write it as a fraction, it's called a rational number. Another example would be 0.3 repeating. So 0.33333333333 until you can't say any more threes. I put a little hat on top of that. That's our repeating bar. That number is 1/3. So any number that can be written as a fraction is called a rational number. If I move down in the boxes, our next group is called integers. So again, they get more specific and precise as you move down. Integers are positive and negative numbers, but they're not fractions. So an example of an integer could be maybe -3 or 5 or 100 or -9. Those are all numbers that are integers. So they're non-fraction form. And then at the very bottom, The last group is called whole numbers. And those are the first numbers that you learned. So whole numbers are only positive. So think about when you started counting, probably when you were 2 or 3, you were counting whole numbers. So those positive numbers starting with 1 and going up. So that would be the left side. These are types of real numbers. We have the rationals, the integers, and the whole numbers. So there are more rational numbers than there are whole numbers because whole numbers are just the numbers 1, 2, 3, and so on. We could write a ton of different fractions. On the other side, the right side, there's one little box. And it goes next to the rational, and it is the other type of number. If it's not rational, we call it irrational. So if we can't write it as a fraction, we call it an irrational number. So these numbers cannot be written as a fraction. So the example I used to the left was 0.75 because we could write that as the fraction of 3/4. An irrational number is just going to be any random decimal. So maybe 0.13579. So they're random fractions. The square root of 3 is considered irrational. The square root of 3 is 2.24, and then it goes blah, 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 blah. It has a whole bunch of decimals after it. But it can never be written as a fraction. So that was a lot to take in. And as I said, we have a lot of vocab terms to talk about today. I'm going to do a quick pause. Does anyone have questions? Use that raise hand feature if you have a question. So we are going to graph numbers on a number line. And there's a little number line drawn for you just to remind you what a number line looks like. Does anybody know what the origin would be on the number line? Think about what value would represent the origin. Can anybody unmute themselves and maybe tell us what number on the number line the origin would be?
0.
Excellent, nice. So the origin is the value of 0 on the number line. So right here is the origin. A coordinate is a point on the number line. So we're going to look at an example to see if we can plot some rational and irrational numbers on the number line. And then your homework will be like this. So the homework tonight will be number lines and you graphing points on the number line. And the number line paper is already on Google Classroom for you to use. So you don't have to draw your own number line. Unless you want to do it yourself, that's fine. So I'm going to go to example 1. And this is what your homework is going to look like. So it's going to say graph the real numbers. So these are all real numbers. We have a fraction of -5/3. We have a square root of 2, and then we have 2.6. The first thing that you need to do is to make all of these numbers into decimals. So I'm going to write change to decimals so that we know where these numbers are on the number line. Because right now, having a square root of 2, I don't know what that number is on the number line. I'm not really sure where the square root of 2 is. So we're going to change them to decimals first. So somebody with a calculator, the first number we have is -5/3. Can somebody tell me, putting that number in your calculator, what does that become as a decimal? -5/3.
-1.6 repeating.
Thank you, Michael. And he said repeating. So that means it's going to go on forever and ever. So that's a fraction that can be written as a decimal, or a decimal that can be written as a fraction. The next one, what is the square root of 2? Again, put that in your calculator. What is the square root of 2 as a decimal? Someone else want to give me an answer for that? The square root of 2 is a decimal? I know you can be brave. Peyton, can you be brave for me? Do you know what the square root of 2 is as a decimal?
1.41.
Thank you. I appreciate you volunteering, or me volunteering for you. All right, so that's what those numbers are. Now we're going to take those numbers and graph them on the number line. So the first number is -1.6. Right here is -1. But I have to go past -1 because it's -1.6. So I'm going to approximate. So we're doing a little bit of approximation. I'm going to zoom in, put a point on the number line in between -1 and -2 because -1.6 is in between those. And then above it, I'm going to write the actual number, -5/3, because that number really represents -5/3. The second number, we have the square root of 2. Peyton said that that was 1.41. So here's a 1 on the number line. Again, I have to go past it. It's positive. It's a little less than halfway, but these number lines are pretty small, so it doesn't have to be exact. And I'm going to write the square root of 2 above it. And then the last one is 2.6. So I'm going to go past 2 because it's beyond 2, a little bit beyond 2, but not quite 3. And I'm going to write 2.6. So that's how most of your homework is going to look. Sometimes it might say to label them or list them in order. So if I wanted to list them in order, that's why we actually use a number line, so that we can order numbers from least to greatest. So now I can write those numbers in order from least to greatest. We're going to do one more example together, and then that is all that we have for today. So if you look underneath at example 2, it says graph the real numbers -1 and -4. So find -1, put a dot. You don't have to write anything above it if it's on the exact value, if it's on the exact integer. Find -4, put another point. So I graph the two numbers. Then it says compare those numbers using the inequalities. We talked about this a little bit last week when we were going over what we're going to kind of think about this year, talk about this year. So it says use the symbols less than or greater than. And I'm looking at -4 since it's on the left, and I'm looking at -1 because it's on the right. -1 is less, -4 is less than -1. So the mouth of the inequality should be facing toward the bigger number. So -4 is less than -1. So those are the notes for today. Some days we will not finish all of the notes that are in the section, and that's okay. I'm going to show you the Google Classroom page so that you can kind of see what it looks like. And this is where your homework will be located. So I'm going to go to classwork. And now we are looking at Chapter 1. Today is Monday, August 31st. And I see that homework right here, Monday, August 31st. And I'm going to click on it. And the instructions tell you exactly the page number. So pages 6 and 7, 21 to 29, 36, 38, 51 to 57 odd. And then I give you graph paper if you want to use it. So there's a PDF attached here that has graph paper. And if you want to use that graph paper, so right here is the graph paper. You can put the problem number above the graph, the number line. Make sure you write the actual problems down. So if it says 3/4, -1/2, and 1, label number 1 and put those problems down, and then graph them on the number line. You can do all of your work on this number line paper. So you can choose to send it to Notability or the Adobe Acrobat app, and then you'll post it back here on Google Classroom. Does anyone have questions? You can send me a private chat if you do have questions or concerns right now. You can also email us. Remember, there are 3 of us, and you can email us. That information is at the very top of the page. Is there anything else that I missed? No? So we are going to stay on the Zoom. You can choose to stay on and start your homework. There's about 10 minutes left in class. Or you can log off and start your homework on your own. Does anyone have questions?
Be sure to ask any questions if you have any. You can also send us emails. You could send us a message on Zoom.
Okay, then thank you so much for coming today. We really appreciate you all joining us, and we hope to see everybody tomorrow at the same time. Again, we are going to remain on Zoom, but you can choose to log out if you wish to do so.